Right now, at this exact second, our collective activity is leaving behind a digital exhaust of global proportions. Every click, swipe, and search is streaming instantly into the void. To put hard numbers to it, over the course of today, the world will generate roughly 300 million terabytes of data. That is the equivalent of every person on Earth taking about 150 billion high-resolution photos in a single 24-hour period. Yet, out of that massive planetary noise, an algorithm on Netflix can isolate your specific habits and recommend the exact documentary you want to watch next. Or consider Google Maps, which can route your car around a highway traffic jam before the gridlock has even fully formed. If you tried to feed all those overlapping variables into a traditional system, like a standard database, it would instantly choke. The sheer influx of inputs would crash a normal computer on contact. These real-time predictions aren't magic. They are the output of an entirely different structural ecosystem. We call it big data. To understand how a predictive algorithm actually functions, we have to look past the interface of your app and examine the raw fuel powering it. We can map this out. This vertical bar chart represents our first challenge, volume. Platforms are pulling from exabytes, billions of gigabytes of accumulated history, like every single video ever uploaded to YouTube. But size alone doesn't explain the complexity. We also have to map velocity. Systems have to process live inputs in milliseconds, whether it's high-frequency stock trades or real-time traffic updates. Otherwise, the data is already obsolete. Finally, we expand into the third dimension, variety. This data isn't sitting in neat, identical rows. It's a chaotic mix of text posts, video streams, pause times, and physical sensor readings, all arriving at the same time. Without a rigorous method to organize this massive, lightning-fast flow of information, any predictive algorithm would be completely paralyzed by the noise. This brings us to the specialized infrastructure required to refine that chaos. Before any analysis happens, the system must solve for a fourth V, veracity. It aggressively filters out fake accounts, eliminates duplicate entries, and blocks corrupted files, establishing a baseline of trust so the algorithm isn't learning from garbage. But even with clean data, we face a logistical hurdle. How does physical hardware crunch an exabyte of information without melting the servers? They abandon the idea of using one giant computer. Instead, they use distributed computing, where the workload is fractured across a widespread network of smaller machines. Think of it like reading a massive library. Instead of one person reading every book sequentially, you hire 1,000 people to each read one page at the same time, and then combine their notes. That is what these cloud nodes are doing in parallel. This leads to the fifth and final dimension, value. The entire purpose of this massive parallel network is to extract a single actionable insight. This pipeline takes a chaotic universe of numbers and refines it down to a concrete action, like predicting the exact product you're going to buy tomorrow. This infrastructure extends beyond the world of retail. These systems now function as the primary architecture for managing global institutions. These exact same parallel pipelines are monitoring ICU patient vitals in real time and cross-referencing symptoms across continents to predict disease outbreaks weeks before they spread. Big data is now the operating language driving logistics, finance, agriculture, and sports analytics. Grasping these 5 V's, volume, velocity, variety, veracity, and value, provides a framework for interpreting how these industries operate. In fields ranging from marketing to healthcare, the capacity to differentiate verified insights from raw noise is now a standard requirement. Mastering these mechanics clarifies the logic behind the data you generate every day. If this breakdown helped you navigate that complexity, drop a like, hit subscribe, and let me know in the comments, what system should we deconstruct next?